Hi guys, good afternoon. We're gonna go ahead and get started here. Before we get started, is there anyone from Team Go Light that's in the Zoom call? I guess they're not here. And then is there anyone from Team 27 Old School in the call?
Yes, sorry. This is
Okay,
Jeffrey White from Team 27, old school.
all right, so we're gonna go ahead and get started. You'll have 4 minutes to do your actual presentation. Please try to be as close to that as you can. And then you'll also have 4 minutes after that for Q&A, and then we'll have a 2-minute buffer in between teams. So each team will have about 10 minutes total to do their presentation, and then a little bit of extra time if you go over just a hair. So the order will be 60 hash slinging slashers, and then we'll go 58 Bot Squad, 27 Old School, 5 Climbers Fan Club, 109 Joey Carter, and then 46 the Two Penguins. So if the judges are ready and if the hash slinging slashers are ready, you guys can go ahead and start presenting.
Can we, are we allowed to share our own screen?
Yeah, that's fine.
All right. Can you see this?
Yeah, looks good. And then just before we get started, judges, are you guys all ready to judge?
Just one question. I'm trying to, it says just chicken form. It says you can only fill the form once. It's not letting me uh, fill the form.
Give me 1 second and I'll look at that.
Thank you. My name is Kunal Mekka. Sorry, please proceed. Yeah.
Also, can we have the team name announced or something before we are starting presenting?
Yeah, I'll make sure that I announce the teams before we start and then make sure that we're going in the correct order as well.
Thank you.
Let me ask someone in the Discord really quick about the judging form.
Are we ready? Okay. Our team made a desktop Spotify player similar to a Spotify car thing that was created. Our team composed of me, Safe, Yusuf Shahzad, and Saram Siddiqui, the hash slinging slashers.
Yep, and so basically our inspiration came from the Spotify car thing, which is a solution for car users who don't have an entertainment system on their dashboard and enables them to enjoy music on their dash. And so we took this design and this idea and implemented our own to for something that you can use on your desk. So with our project, the components we used were a Raspberry Pi 4, LCD display, buttons, LEDs, user interaction, a breadboard, resistors, repeated circuit structures, switch debouncing, which was implemented in our software, in our Python script, as well as the Spotify API. Here is what our project looks like. So when you press this first button, it pauses the track, and the LED light indicates that it's paused. When you press the second light, it skips the track forward, which also the LED light indicates. And then the final button rewinds the track. So this was just a very basic implementation. Moving forward, what we would like to do is include casing around the entire product so that it looks like something that someone would actually want on their desk with 3 simple buttons and the display. And that is all. Thank you.
Right, now we can go ahead and get started with Q&A. So if the judges have any questions, feel free to ask.
Hi. The display you showed, like, is it the car's inbuilt display, or you are gonna add the display device on the car?
So this was the car one already actually exists. This was the we just used the car one as the inspiration for one that you could just use on your desk.
Okay, got it.
Okay, so are you plugging like headphones directly into this, or does it connect to your computer and you control the tracks from there?
So actually the LCD display also has its own speaker. So on that the audio will be able to come out straight from there. But at the same time, since it's on a Spotify, you can control you wanted to play on another device too, you'd be able to control on any device.
Okay, sweet.
So, what I understand is that you guys implemented like control keys for an already built Spotify player, right? So your control keys are controlling the Spotify player.
So actually, what we did is that we are interacting with the Spotify API to make our to make a Spotify player. Um, we didn't use the already made Spotify player and then just made buttons for it. We actually used this Spotify API to do it all.
Okay.
So what is the new feature you are bringing in? The Spotify doesn't provide that. I believe they should, right? So this is another implementation of that feature, or is there anything new?
Yeah, the current implementation of the car thing can only be used in a car. And we felt that sometimes for Spotify users, they might have the need or the want to be able to have that system easily and readily available on their desk, which is why we made something that's actually able to be used on your desk.
Okay. So I can use the Spotify app as well, right?
Yeah, and it's supposed to be just like if you're working and you don't want to switch desktops or you don't want to touch your phone or they're already preoccupied in other tasks, then you're able to press the button, um, you know, and lift yourself from any distractions.
Got it. Thanks.
Can you say a little bit about the coding environment that you use to work with the API?
Yeah, so we use the uh since it was built on a Raspberry Pi, we use the Raspberry Pi OS and we built it all on Python. We use um the Spotify framework basically that allows us to interact with the API itself, creating uh, an ability to log into your own Spotify account, and it has its own authentication. And then after the users, given the authentication code and the token to the API back to our code, we're able to connect to their devices.
Thank you.
Were there any more questions or anything that you guys wanted to add?
What would be a good kind of a second version of this one? Like you said, it's a basic prototype, right? Like
Yeah.
if you had like another week or so, what would you add to this?
Yeah, so our idea actually was that we were gonna 3D print a whole case model, so then it's something that can sit on your desk and hide all the wiring.
Yeah.
As well as, we are also thinking of adding, an LED backlight that is responsive to the music, the music sounds, so to make it more, enjoyable for the user.
Got it. Okay. Yeah. Thanks.
Do you know if any such product exists today in the market or other than the app?
Currently, no.
And how was your experience? Like, did you all already knew Python or you learned it? How was your experience coding it?
We knew Python, but this is our first time interacting with the Raspberry Pi. So that itself was a learning curve for us, to be able to create everything and then also work with their OS system since we've only had experience with an Arduino.
All right, okay. Thanks.
I have one question. Like, you have option for forwarding and then reversing the tracks, right? So how we are selecting the songs in case if I want to change the track?
Could you repeat that question?
No, you have like 3 buttons you mentioned, right, as a part
Yeah.
of this project. So one is for like pass and then forward and then reverse the track, right? So
Right.
how to navigate to the different songs or tracks? Do you have the feature or is it like not yet built?
Currently that's not something that we have implemented. We just wanted to keep it simple for the user.
Okay.
Yeah.
Okay, got it. Thanks.
All right, if nobody has any more questions, we can go ahead and wrap up the first presentation. I should also add, like, if you guys want to show a part of your product too, feel free to turn on your cameras and demonstrate your like physical product if there's anything you want to show up close. So next we'll have team 27, and then on deck after them we'll have team 5. So we'll give everybody a minute to get set up. And then just let me know when you're ready, team 27, and when the judges are ready.
Just okay. Are you guys able to see the screen here?
Yep, that looks good.
Yes.
Okay. Perfect. So my name is Jeffrey Wen, and I'm presenting for Team 27 Old School, and I worked with Sarav Shastri. And we're excited to present our project Scribe.ai, which is a AI medical scribing tool. So the problem that we're trying to solve is that physicians end up doing a lot of documentation while they're working. In fact, they found that on average, physicians spend 16 minutes and 14 seconds on documenting with electronic health records after meeting with each patient. And oftentimes that's actually even longer than the interaction they have with the patient itself. So this results in doctors seeing fewer patients, which results in higher healthcare costs, but it also results in physician burnout because physicians are having to spend a lot of this extra time just doing paperwork. And because they're more tired, that also leads to more inaccurate documentation. So our approach is that we wanted to present this to an AI large language model because those are very good at summarizing data. So we created an app
Excuse me,
where
yeah.
it
Sorry, your
Yep.
screen is not completely visible. I'm able to like not see the full screen. If you can like minimize the participants tab.
minimize. Let's see. Okay, is that better?
It's kind of better, yeah.
It is better, at least.
Okay. Sorry about that. Let me see if I can make it even more. Okay. Are you able to see more of it now?
Mhm.
Okay.
Yeah.
Okay. Sorry about that. So the way our app works is it records the interaction between the doctor and the patient. So the doctor is able to see their patient as normal. And then that audio file is sent to be transcribed by OpenAI's Whisper machine learning model. And so it's automatically transcribed, and then that transcription is sent to a large language model in order to be summarized in an efficient way and in the proper format for an electronic health record system. The physician then is given back that summarization, and they're able to make edits as they see fit, and then they can copy and paste that into their database. And then just like that, they're done. We designed this in Flutter, so it's able to work on iOS and Android, but it can also work on Mac OS and Windows. So it's very multi-platform. And then here we have an example of it working.
You click start record, and then you see your patient is normal. Hi, my name is Dr. John. I'm going to be seeing you today. Can you please confirm your date of birth?
Yes, it is 9/22/99.
Okay, and what brings you in today?
I've been having some pain in my left knee while I run.
And I'm forwarding it here for sake of time, but.
And then you stop the recording, and it takes a little bit to transcribe. And then after about a minute, then you have your full transcription here, along with the generated note listing the symptoms, patient history, potential causes, the treatment, and potential diagnoses.
So in the future, we have three main objectives we'd like to do. One is to ensure it's HIPAA compliant so that doctors are able to use it without having any complications with the legal system. Secondly, it'd be nice if we could integrate imaging into it as well. If you could include MRI or X-ray scans in, and then also use a machine learning model to help try to diagnose what is seen in those images. And then lastly, it'd be nice if we were able to have access to the entire database of the patient's history and then summarize that all before they even see the patient. So that way they don't have to go through all of the documentation of the patient's history. They can just get a quick glimpse and overview of what the patient's history is. So with that, we hope you enjoyed our project, and I am open to any questions.
Hi, Jeffrey, this is Kunal. A quick question. Do you know if there are any such products in the market currently?
Yeah. So I actually got this idea because my sister is a physician in the ER, and she's been trying out some of these medical AI scribes as well. They do have several different versions. The problem is a lot of them are very expensive. I know Epics, which is the big electronic medical record company, is working on one, but any kind of upgrade to those kind of systems costs millions and millions of dollars. And then there's a few just apps, but it doesn't offer really any kind of customization into what the final product comes out to be. So what kind of format you want it to be, you don't really have control over that. So with this, we're hoping to be able to better customize that for the physician's need.
Okay. So are you using API? What kind of API, or like what kind of what's your implementation methodology behind this?
Yeah, so
go ahead.
So I implemented it in Flutter. But with that, I'm using an API to connect to OpenAI, and then as well as the Google Gemini products. So they have packages for Flutter to be able to communicate with those APIs. And then I also have a recording package integrated with Flutter to be able to record the messages, store it on device, and then be able to send that to OpenAI for the transcription.
Okay. So just a quick question, another question here. So does it need to doesn't need to be fed with existing EHR terminology to be able to record those stuff correctly. And like you said, it's suggesting a treatment which gets edited by the doctor or physician before copying it in the database, like EHR database. So do you think there is some authenticity in what it records and suggests to doctors, and it actually saves time that way?
Right. So actually what it's transcribing and then generating in there are suggestions by the doctor. So if the doctor offers possible diagnoses, then it'll include that as well. But one thing when I was talking with my sister of a product like this is she was interested in it offering some of the potential options to rule out. Because as a doctor, when you're making these decisions, you want to list out the different things that you rule out. So she was also suggesting that it would be nice if they would give you some of those kind of counter examples to then you can show your decision-making process. So it includes what the doctor says is the diagnosis, but also might suggest some potential options for the doctor to include or not include.
Okay, thank you. That helps.
Thanks.
Just a follow-up question on that. So does your implementation include that feature where the system is providing suggestion or to the doctor? I thought like your implementation is mainly it's converting the notes to proper, like whatever the discussion happening, it's scribing it and then converting into the notes for the doctor.
Right. So sometimes it does do that. And on this slide, I have an example of kind of what that generated node looked like. So you can see under potential causes, it lists like a ligament injury, a meniscus tear. And those were the two things I mentioned in the text. But then down below it, it says other potential causes, which are, sorry, I'm not very good at medical words, but bursitis or tendinous. And those were actually things that it suggested on its own. So within the prompt, we can explicitly ask it to give other suggestions or more suggestions. Here we've kind of done a mild thing where we're like, offer the potential causes the doctor says, but then also in some cases offer additional possible causes or diagnoses.
Got it. One more question, like, so I'm assuming there must be a lot of these ML or the models must be available, which you used, right?
Right.
How coding did you have to do, like, using these models? What are these like readily available libraries and you guys used it?
Yeah, so for this kind of stuff, we want a high performance model. So even though there are available ones, like the smaller like llama models from Facebook, one, they require a lot of processing. So it wouldn't be very convenient to have it on your phone and be able to process it. So in this case, we're using OpenAI's Whisper model, which they do have open source, but I'm using their API, so it's running on their server. And then the Gemini Pro 1.0 model, which is also a very large language model. So for the sake of performance, we didn't try to use any local models, but they do offer model tuning. So in the future, it would be nice to have many different examples of what the transcript is and then what the doctor is looking for in their note, and then be able to use that as kind of a guide for what the model should provide.
Got it. And for the user interface, you were showing on a laptop, right? So what did you like? Was it a web-based or?
It was not a web-based. I started off trying to do a web-based one. The issue that I had was that with the voice recording, it wasn't really able to save anywhere first before being sent off. So then I switched to a macOS app.
Okay.
But because it's using Flutter, it's designed to be multi-platform. So it should very easily be able to be put into iOS and Android as well as a Windows application.
Got it. So I'm assuming like you did make a Mac app for this?
I made a Flutter app, which then you can generate macOS code.
Got it. Okay.
Yeah.
Thanks.
Hey, when I have a quick question on the accuracy model of the algorithm you might be using for this one. So do you have any accuracy like 0.9 or 0.100, something like that, which every machine learning model should be having if in case you're using here?
Sorry, you said you were saying accuracy?
Yeah, the accuracy, the percentage of accuracy. Have you identified that?
Yeah, no. So in this time, I was really just kind of a proof of concept. So I'm not able to test the accuracy. I also kind of need like an expert in the field to be able to assess the accuracy of it. But what's nice about this is as long as it's able to accurately transcribe the transcription, then the doctor's also looking at it. So it's not like any big medical decisions are being made without the consent of a doctor. This is really just trying to put the doctor's words onto paper or onto electronic records, so that they can then later on save a lot of time.
All right. So on the follow-up question, so I see, so where exactly this data is getting stored in the backend? And what is the, I see the front end I can see here, but what is the backend for this whole process?
Yeah, so in this case, I didn't implement a backend. I had tried to, I was having some problems with it, but for this implementation, it's just stored on the device and then it's being sent out and then presented, the results are being presented back onto the front end. So there's no backend interface right now.
All right. Thank you.
Yep.
All right, guys, it has been about 10 minutes. So we are going to have to move on from this presentation. Thank you for sharing. And next we will have team. Sorry, let me look back at my order here. Next we will have team 5, and then after them we will have team 109 on deck. So you can go ahead and share your screen if you're ready, team 5. We'll give you guys a second to get set up and also the judges a second to get set up.
Yeah, just quick question here. Maybe you can clarify, Eliza. So these teams have only got a couple of like a day and a half to get theirs implemented, right? Is that correct? Yeah. So I think as a judge, we should have expectations of what this can be done within a day, and also the scope, right? So just speaking that loud, and I think we should be fair to each one if we have like if we obey the same time limit. Just my thoughts. Please correct me if that's not correct.
Yeah, we're trying to keep it, so we have about 10 minutes per presentation. So we're just trying to do about 4 for the actual presentation, and then we'll move into discussion for the remaining time. And then if we have a little bit of extra time left in that 10 minutes, we can continue discussion if it's still going. And then I'll try to be on top of it to cut things off right at the 10-minute mark.
Thank you.
All right. Can you guys see my screen?
Yep.
All right, perfect. Thank you. Thank you. All right, are my other 2 team members here?
Yep.
All right, good stuff. Katie, are you here?
Yep.
All right. So let's get this started then.
All right. Hi, everyone. We're Team 5, Climbers Fan Club, and we created MicroLab, which we're really excited to share with you today. What was the challenge that we aimed to fix was the barrier of young children getting into STEM and making the introduction to coding for middle school age children less intimidating, and also eliminating the need for a complicated setup of electronic components for teachers who may be working with lots of students and may need to have accommodations for each one. What did we do to counteract this was create an easier way to code for younger audiences, and this easier way of coding promotes success to encourage young students to study electronics and coding. And then also everything you need comes assembled in a concise box for ease of use.
With that, we are introducing to you today MicroLab. Encased in a 3D printed shell, this box allows for an exploration of simple hardware components without the risk or worry of damaging the sensitive wiring and components on the inside, allowing students to try their hands at programming without tearing up resistors everywhere. So what does MicroLab do? MicroLab aims to provide a way for children to learn how to program with a simpler programming interface that utilizes a wrapper that can convert simple commands into an Arduino script. MicroLab can be an affordable and accessible alternative to other products on the market for younger kids, namely like middle school range, interested in microcontrollers or STEM in general. Inside the box, each of the components is controlled by an Arduino Nano, in which there are 3 button inputs and 4 LED outputs, a buzzer output, and an LCD screen writable output, in which a USB-C port is used for both the power and for programming.
Now you're probably wondering, what about this new programming interface that we have? We created a custom programming language called MicroLang that allows for simple control structures with if, else if, and else conditionals that can also be nested, as well as finite loops using a simple for loop-esque structure that is easy for students to understand. We have the functionality to print to an LCD screen with a single command, the ability to read the button inputs with single word command, and control the on-off state of the LED and buzzer as well. Now, if you look over here, we have an example program written in MicroLang. This program is interpreted by a wrapper written in Python and is then compiled into Arduino program that can be sent to the microlab. So here, this simple program will open by being the program title, which is given to the Arduino file name. Then it's going to print to the screen. And we just have a simple if, else, if sequence that can read button states and control light states using simple on and off commands. And you can see that being compiled and run right here. So we think with this kind of interface, students can jump into text-based code in a simple, natural language way that prevents from all the abstractions of C++ oriented coding that comes with Arduinos, and a really customizable package that can have curriculum and projects designed around it. All right, thank you so much. If you have any questions, let us know now.
So this is Steve Bibick. Can you hear me?
Yes, I can hear you.
So nice idea. Have you looked at, so this has been done for a while, and have you looked like at Scratch or any of your competitors?
Yeah, so that was a big thing. So I actually worked last year in educational microcontroller spaces. So the problem with Scratch is I think that visual scripting languages take a little bit of like too much of that like control away from like early learners. While visualizations are really good, it also isn't how we code in the real world. And introductions to like those text-based programming, I think was a really like new idea that I hadn't seen before. And then the other side of things, where I worked specifically in the past, was they were good hardware kits, but asking students to write code directly in Arduino was such a tall order that it becomes really difficult, especially even just for teachers to keep up with it.
I agree with your assessment. Very good.
Can you explain a bit more about how you compile the MicroLang into Arduino? Like,
Yeah, it's actually really simple. So what I did was I just wrote like a file reader in Python that just iterates over it, and then just one-to-ones the keywords by parsing out the strings into like Arduino code itself. So it literally just goes, hey, look, I have an if statement here. This is what's inside of it. Let's convert this to an Arduino if statement, right?
okay.
So can you show the box again? What is the hardware that the kid's getting experience with?
Yeah, here. I don't have a camera, but I'll share my screen again real quick. So the box itself, we inside is a breadboard with an Arduino Nano on it. And then those are that we have another smaller breadboard that we soldered those 3 buttons onto that is then wired on top of the main one. Then the LCD screen is just and the LED buttons are also wired straight onto this breadboard with the Arduino on it. Then on the side, you see the buzzers like sticking out here, and that can be interfaced with to make some down. And then we have this USB slot that you can plug it into your computer with. So it's really like basic hardware. And in the future, we would love to be able to expand it with more parts, but we kind of just wanted to work within the scope of the kit that we had for MakeOHI. And this is what we kind of came up with for the form factor we were going for.
Yeah, I was having trouble seeing
Yeah,
your
we don't see
thing,
your
but
screen, Lance.
Oh, you don't see my screen?
yeah, it's just double clicked to something. It's giving some kind of, but basically, the people are the kids are hitting buttons to correspond to different programming actions that they performed.
If
Right,
you would,
exactly.
give me one
Yeah,
moment,
okay.
I can show you a peek inside the box from The
No, I wanted
forward.
I wanted to get a feel for what was the hardware that the kid was interacting with. So they're basically, it's kind of like hitting buttons and things. So, um, so
Yeah.
one suggestion. I don't know if you ever seen a MakeOHI, but that has that you know is programmed in Scratch and allows you to connect different fruits and things to like a mouse interface. But so think I think this would be a great addition for MakeOHI if you ever look that up.
Yeah. Yeah, I think the big thing we wanted to do here was we felt like we had a limited scope with the hardware, and I think that we saw a real gap in the way that educational scripting is done right now. And we kind of want to like create this in between for text-based coding and then these visual scripting solutions that exist.
Yeah, yeah.
For
Go ahead and
example,
stop the share because it's not showing anything.
Oh, that's so bizarre. I'm sorry about that, guys.
Can you just help me understand a little bit again? Like, so by pressing the buttons, like the students are following the color sequence to like do that if else loop or
Yeah, so like the code that I showed during the presentation, that is like the idea was it was like a simple program that I just wrote up to demo how the language works. And if you press a button, it just toggles which light is on. So it just switches like based on which button you pressed. That's like one of the many different coding things you could write. You could write something where you press a button and the buzzer makes a different beep, or you want to press a button to change what's written on the LCD screen, or maybe like create a sequence of lights in a different design pattern or something like that.
sorry to interrupt. Can you see this image that I'm trying to share, or is this not working?
Yeah, we can see it. Yeah.
Okay.
Yeah, it's showing the inside of the box.
Yes.
Yep.
I got a quick question about kind of the programming interface. Are at the moment are people just putting text files directly in, or do you have like a companion app that people are using to program with it?
Yes, that's a great question. Currently, you actually have to put the like dot microlaying file into a command line interface. Our thing, if we have more time, what I would have loved to have done is made a desktop app that allows us to like wrap it to Arduino and then compile and upload all in one place, so you don't have to like take the Arduino code and then put it into the Arduino IDE, right, and then send it off. I think that would have been a really great feature to like add if we were to have more time to progress it.
Sweet, thank you.
Yeah.
Yeah, this is a great work, I would say. And Gordon. But one quick question, like in the coming future, because of the introduction of AI, where everybody is, there's a buzzword of no code programming, most of the work will be done by AI. So how fruitful this will be?
I actually think that there's a lot of room in this space to really allow AI to step in and help. And as we've seen, in some instances, AI can struggle with programming, but in other instances, not so much. And one thing that's great is this programming language is really, really easy to interpret and understand. And I think it could be some kind of feature to expand in the future where you have like AI assistant, like a little personal tutor that can come with the curriculum. Say you're a student who buys this for yourself, and we had like a website that comes with this product, and you could be able to get real-time feedback and engagement on your code, or you want to learn how to do something. I think that's a big opportunity as well, that is very easily able to be expanded on in this space.
Thank you.
Right, if that's the end of the discussion for this one, we can go ahead and conclude the presentation. Next, we will have team 109. That's Joey Carter, and then after them, we will have team 46 going. So we'll give you guys all a second here to get ready and get your presentation started.
Okay, sorry, video. Yeah, go ahead. I didn't know how you could screen share the slides. My God, wait, what? Why is it not working? Okay, there we go. There we go. Okay, can you see our slides?
Not
You
yet.
can, you can see us on the slides? Oh.
No, I just see some Chinese characters.
Oh my God. Where's the frick? You know what? Let me just share the entire screen.
Now we can see them.
Yeah, now we can see it, right?
See it now? I'm so sorry. I'm confused. Can you see it when we're not full screen like this?
We can
Yeah.
see something called bubble popper alarm.
Yes, okay. So perfect. Okay. Do we begin now?
Yep, you guys are good to go.
Okay, so sorry about that. I'm Carter Blessing, and this is Yu Chu. And this is our first Makeathon. We joined this Makeathon for last project, and we created the bubble popper alarm. What we created is a little module here. It has an ultrasonic sensor, and it alarms you if you're too close. It has a breadboard, GPIO, LCD, lights, a buzzer, and a potentiometer. This is a prototype, and in the future we could see this being used on like one of our ideas was like in museums if you're too close to artwork. This thing can it'll tell you if you're too close to the artwork with a LCD, a buzzer, and LEDs. It could also be used on like maybe a cap or a vest. Like I said, we used a breadboard, a GPIO. We have an LCD. We have two LEDs. We have an ultrasonic sensor, which is the main component to this, a buzzer and a potentiometer. Before I get into the code, can we let's show them that. Oh, okay. How it works. Let me just so you can see. Yeah, okay. Because you can see the one side. So here is our creation. As you can see, blue light, and it says you are good. Nothing's in range. And we set a threshold of 15 centimeters to start, and this could be altered, but if we get too close, it screams, the light turns on, and it says, too close, go away. Okay. Our creation is pretty simple. We coded a little bit in the Arduino software. And it's pretty self-explanatory. If you're too close to it, the alarm goes off. The LCD displays that you're too close and to go away, and the LED switches to the red light. Versus when you're not too close, blue light's on, there's no buzzer, and the LCD displays that you're good. And that is our Makeathon project.
All right, we can go ahead and open it up for any Q&A if there's any questions.
How do I?
So what was the kit that you used to make this?
We used the Mega 2560 Mega Arduino kit.
Was it the Sunfounder kit or was it the ELO kit or?
Sunfounder.
Are you guys in the CSE circuits course?
Yes, sir.
Very good. So, and I know a little bit about that course. So have you thought about using more than one sensor and sort of seeing if you can combine different sensors?
I suppose, I mean, I think that's a very good idea. Our best idea so far going to up to this prototype was the museum idea where, I mean, maybe we use multiple sensors so that it's sensing multiple directions, but right now it's only one dimensional. And yeah, keeping people away from artwork in museums.
Right. But there's more. So have you guys ever heard of the Connect box?
No, sir.
Yeah, it's an old technology made by Microsoft. And they combined kind of ultrasound sensing with infrared sensing just to sort of see what information you get from the different sensors.
Okay, cool.
And I think you have an infrared sensor in the kit, if I remember right.
I believe you're correct.
Yeah, very nice, very nice.
Thank you.
So did you have any things go wrong that you had a struggle with?
Yeah, we tried to implement I forget the name of the sensor that collects humidity. We tried to
The
implement that
humiture.
whatever that was, we weren't able to get that working with the ultrasonic sensor.
Oh, so you did try to do multiple sensors. Very good.
We did try to use multiple sensors, yes.
Yeah, yeah.
Still with the idea of preserving our work in mind. So humidity and people staying away.
How accurate can you make the parameters in terms of what distance it triggers the alarm?
So from my knowledge, the ultrasonic sensor in our kit can read up to 121 centimeters in distance, which obviously, just given what we have, I don't know if you were making this a bigger thing, that's not great. But from what we measured, it is pretty accurate. We had it set to 15 centimeters, which was pretty close. And the only reason we kind of set it to 15 was because it was screaming at us the whole time we were working on it. So from 0 to 121 is how far I can measure.
Thank you.
Yep.
Hey, I have a quick question. So in case if you are adding multiple sensors, right? So do you need to require to recode or anything, or is it like already it's handled to like capture the sensor details from multiple sensors?
Are you saying if I had multiple sensors?
Yeah. So currently it is having one sensor, right? So in case if you are going to implement this project in museum or something, right? So if you want to have a multiple sensors, so does it require any rework in your project, or is it like will it be able to handle it?
I'm sure it would require a little bit of reworking, some spaghettiing of wires, and I probably need a little bit more code.
Okay.
Yeah, I'm sure it wouldn't be too much work, but it would definitely I'd have to add some stuff.
Just a follow-up question on that one. So like if you have multiple sensors, right? So it will be like getting inputs from multiple sensors, right? So in case if somebody is moving close to one sensor and in case the other sensor are not emitting, right? So does it, how do you handle that one?
I'm sorry, can you repeat that?
No, if you're having multiple sensors and like and you'll be having a threshold of 15 or like 50 centimeters something, right? So if a person or object is moving close to one sensor within that threshold limit, but whereas in another sensor they are moving in a different threshold. So how do you handle that? So which will be displayed in this?
Yeah, good question. In the idea of what we were thinking with the museum and artwork, I suppose that if you break that threshold in any of the sensors, then the alarm would go off.
Okay.
Yeah.
Okay, got it. Thank you.
Yep.
All right, I think that's going to be it for 109. We've reached the 8-minute mark, so you guys are good. Thanks for the presentation. Next, we'll have team 46 going, and then following them, we'll have 58. And that will be the end of our judging room. So team 46, whenever you guys are ready and get your presentation up, we can go ahead, and we'll give the judges a second to get set as well.
Sure, I'll be sharing the presentation. Is everyone able to see the slides?
Yep.
And okay. And Nozomi will be starting for us.
Yep. Okay, hello, we are team 46 and we're excited to present our Whack-A-Mole project, which we also did for our CSE circuits class. For this project, players have the choice to choose from 3 difficulties, and the interval that the user will have to press the button decreases as the difficulty increases. We integrated a series of LEDs that lights up at random to represent the moles, and push buttons that corresponds to them. If the user misses the mole or doesn't press the button within the set interval, the buzzer will make a sound to alert the player. And this is a demonstration of our project. Users will have the option to choose the difficulty level, and the game will run for 10 moles. And the score will be shown on the LCD display, which is at the top. And the buzzer will beep when the user misses. And at the very end of the game, the LCD display will display the final score and indicate that the game is over. And then this is a close-up view of our setup.
These are the list of materials that we use to build the program. And here is the code that we will be providing our users with for the Whack-A-Mole game, and it will take you to this link where the code is present. This is the close-up of our setup that we had. It just shows where all the wires are and what components go where. And the social impact of our game is it's targeted for high schoolers. It gives them an easy project that can be recreated given the materials code and the setup provided. By creating a fun, hands-on, customizable project, it will motivate young students to gain an interest in exploring STEM.
So what makes our project different from others that are currently on the market? We noticed that there are currently like different games that you can create with Arduino projects, such including Whack-A-Mole, but it was very specific in that you had to buy specific components to make it work. So ours was limited by the Sunfounder starter kit. So all the components that we used were from the kit, and we just had to use 3 extra breadboards, which are all materials that are purchasable on Amazon, which makes it very accessible for parents who have high school students interested in ECE and programming to buy this kit to make our product and also reuse these materials for future projects. And then we also included in our kit full documentation of the code with detailed comments to make it easy for people who are just beginning to learn to code to understand and read through. There's also a video that we showed of the project fully set up with a clear overview of the components, which allows the students to figure out how to piece the wires and different transistors and components together without providing step-by-step instructions. So it lets them have some creativity and freedom to problem solve. And then we also made it so that our code is fully customizable, as the users can modify the gain speed with a constant listed in the code, enact multiple moles by changing it so multiple lights light up at once, and other such modifications. The components itself was kept simple, so it encourages creative modifications on the circuit itself. And it also users could do things such as adding more buttons or spacing them in more challenging orientations. And our project wants to promote learning for students to not only understand how ECE components and CSE coding works, but also to apply their knowledge to make creative choices themselves. And that's the end of it.
So you guys mentioned about the reaction time. You have like 3 different settings for reaction times. Is there a way you guys can like randomize it for each turn so that there's no like set sequence? Have you considered that?
We could. The only reason we didn't was we wanted to implement the 3 difficulty modes, so it was a predictable of, oh, if I'm trying the easy one, I'll get like 1 second to react, and the hard mode is the one that goes really fast, but it would be an easy change to modify it so the reaction time is random.
Yeah, that's nice.
So this is Steve again, and that's really nice project, girls. And how many of you are on the team?
There's 3 of us.
Okay. And did you think about, I mean, I really love the idea of letting it be open-ended so that whoever gets the kit can sort of make things. Did you think about suggesting sound at all, or?
We have a buzzer that beeps, but just in the video while we were presenting, it was not going off. But if you go and look into the video, like we can share the slides. Do you want to try again, Carmen, to see
No,
if you can?
that's okay. If you added the sound, that because I knew it comes with a buzzer, so that's
Yeah,
pretty cool.
the buzzer did go off twice in the video, but I think we just couldn't hear it because it was in a presentation.
And then I don't think you should necessarily use as a negative that you might want to add some other parts that don't come with the kit. So again, there are these really fun educational kits like a MakeOHI that when combined with the Sunfounder would give you sort of unlimited creative options. And I really like your idea of letting the, you know, the whoever the high school students are, you know, let them invent a little bit on their own. And very nice presentation, by the way, really well informative, really well organized. Nice job.
Thank you. We wanted to go with this kit because it's just a smaller kit. So it's like just to get them started, because I know some parents don't want to buy more than one kit. It's like this kit has many basic components, which are also like budget friendly. So if they are interested in it, they can go and buy more. And we just wanted to start at like basic. So it's like so they can get started on it. We wanted to focus on budget.
I agree, and I think you made the right choice. But I think you have a really good idea here. I would encourage you to keep working on this for Show Ohio, which is about a month from now. And I really think that you can offer these options so you can give the parents, you know, here's your starter kit, you know, $40 or whatever, but then here's these other things that you suggest to them and actually go and get some of those things and try them because you'll get a lot more creativity. And this would be a wonderful thing to make for, I really love this idea. You did a nice job.
Thank you. We'll look into that. We'll try to add more things to it.
All right, if there's no more questions, we can go ahead and wrap up the presentation. Thank you guys. Next we'll have team 58, and that will be the last team of the day. After that, I think that's going to conclude our judging session. So team 58, whenever you guys are ready, you can go ahead and start presenting, and then the judges whenever you guys are ready as well.
All right, I'll share my screen. Let me know when you guys can see that.
We can see it.
All right.
Can everyone hear me?
Yep.
Awesome. So welcome to MakeOHI. This is a all-in-one user-friendly home security and communication management platform that acts more as a companion than an application. And through our demo, we will clearly outline the numerous features of MakeOHI, including but not limited to facial recognition and a 24/7 emergency chatbot. And all of these will show why MakeOHI is a must-have in modern homes today.
So the problem that we stated is that there's actually no streamlined safety application right now in the market. There's not really any personalization to those applications, and it doesn't really have motion detection, and it's not as consistent as what we want it to be.
And then, as Jay mentioned before, some of the features included in our web application include face detection, text messages systems, sound level threats, home safety dashboard, and a chatbot system.
So our tech stack consists of many different features. We have different AI models to show the facial detection. So it trains your face, and then it tells you if you can be locked inside the door, if you can go inside the home or not. We also use Node.js and Twilio's API to get text messaging systems. We also use React.js and Tailwind for front end development as well.
And so now I'll hand it off to Rahul to give us a demo of our product.
Oh, can you guys see my screen?
Yeah.
Cool. So. Okay. That, and I'll also turn on my camera. Okay, so yeah, so I'll just start off by one showing what these features are. So in the middle, with the camera, you see that is the facial detection feature. Basically, right now you're seeing face not recognized because the person that's in front of this camera, Rahul Nalam, he is not trained within our model. So essentially how this works is in the top left, you would see an add new user, and because of time constraints, we weren't able to make this like a dynamic model where you can continuously add people. But basically, when you set it up, you can train your model to detect 4 faces or 3 faces, depending on who you want to let enter your home. But basically, we thought of this as the 4 members of a family or 3 members of a family. You would train your model on the 4 members, and only those 4 faces can unlock your home's door. And in the future, we want to make it so that suppose your grandparents come and live with you, you can now add a new user to this Notify app, and you can train the model on their face too. So it's basically how facial detection works on an iPhone. So that's that. And then right below that, you see a current decibel level. And it's like currently measuring the decibels wherever Rahul is sitting right now. Basically, this is for like older people where if a noise is detected that is a little louder than the norm, you would get notified of that. Or if there's something outside of the house that you hear, such as a gunshot or something like that, this decibel level would catch it and send you a message through that Twilio API. In the bottom left, you would see like a question mark. That's our live chatbot. And so basically what this can do, we did not have time to properly integrate this, but if someone, say for example, is in the house and they run into an emergency where they're not able to like get up or like ask for help right away, you can go through this chatbot and say, for example, call 911 or call the like call the fire department, something like that. And this will directly call the fire department or the police station to get help. And later on, we will talk about in future implementations where we were going to use this thing called Bluetooth Low Energy, BLE, where it will track where you are in the house um, based on BLE as long as you're connected to the Wi-Fi. So the responders that are coming to help you in your emergency, the police officers or the ambulance, you won't have to notify them of where you are in the house. They will see automatically through this app where you are. But just in general, like you can ask this chatbot any sort of emergency question. Like if you get a cut or a burn, you can ask what should be my first steps or anything like that. And that's chatbot is always there to help you. And then as we said, this is a communication platform as well. So at the top, you're going to see just regular summaries of how many people came into your house or like the highest audio measurement that you've seen, or if you have guests over, how many of those people are coming. And then you can basically customize this to whatever you want. If you want to see who is the most frequent guest to your home, you can see that for our project up until now in the top right, you see the most recent guests. So the person that is not a part of your family that just entered your house or just left your house, you would see that. And then right on the right of this camera, you see a before you came back.
Basically, it's as I said, this is a companion as well. So anytime it detects a family member leaving the house, it will send you a list or a text message of things that you should complete before you come back, just as a reminder. And then to make this even better, with the users, we want to make the tasks personalized where they have their own account, and can put their tasks in. So, depending on which user detects that leaves the house, it'll send those specific tasks to that user. And yeah, that's basically it. That's what our UI look like. The thing that we want to point out the most is just how user-friendly and easy to look at this whole platform is. I know there are things out on the market, such as Ring is probably what you guys are thinking of right now. But what separates us from Ring is how user-friendly our platform is. Um, and yeah, that's basically our demo.
We also got like a lot of market validation from other people, and they also said, yeah, this product is a lot better than what I currently have and the Ring camera, and we actually got a lot of support from that as well.
All right, guys, at this point, we are going to have to transition into the QA. So if the judges have any questions, feel free to ask. And then if you guys want to add anything else in response to those questions, feel free to do so.
Okay, great idea. One question, like for this project, I believe you didn't do any hardware integration. Is that right? Or you did, you use like laptop camera or something like that?
Yeah, I can talk a little bit about that. Yeah, so due to time constraints, we couldn't really figure out how to actually build a doorbell camera and also integrate it with like a BLE sensor, a Bluetooth Low Energy sensor, like Jay was talking about a little earlier. So we decided to just go with the software version, and get our camera to actually run the AI model to see if that works out in our favor a little bit more.
Got it. And the idea of that Bluetooth energy meter. So would it be like two different hardware pieces? Like one is the front door camera, and then this another thing, or would it be integrated? Would it be part of your door lock?
Yep. So it's actually integrated into the like I guess like the camera itself. So what happens is like what the user flow we want it to be is once the user enters the house, it automatically connects to the doorbell camera, and the camera will have like a map layout of your house, and each phone has its own user base like created. So you know,
First time when it is recognizing a person, then it will track that person throughout the home, something like that.
exactly.
And it's only when you want it to. So you can actually click when you call like 911, you can click on the app, yo, track me right now. So it's safety reasons as well.
Got it.
What does
So-
the oh, sorry.
Oh, sorry, you can go ahead.
What does the facial training process look like at the moment?
Yeah, I can talk a little bit about that. So, there's a platform called Google's Teachable Machine that we used. Um, and basically it's a model that right now you can have like facial detection, and current facial detection algorithms, they mostly just detect a human face, but it's uh besides like the facial detection on our phones and stuff, um, the ones that are out there, they detect just human faces and aren't able to accurately identify who it is. So Google's Teachable Machine is what we used, where you can train it on our individual faces, and it automatically will update like we automatically update our model based on that new face. Um, and so anytime you want to add a new user, we would it basically is the exact same process of how you um like put your Face ID in your iPhone. And it'll like dynamically update your model, and that it will like start to recognize your face after that.
All right, guys, unfortunately, we are out of time here. So I'm going to have to cut you off, keep it fair to the other teams. But thank you for presenting. And judges, thank you for being here. Thank you for taking the time out of your day to judge. And thank you for all the great questions. Good job to everyone that presented. Everything was great, and I hope you guys had fun and enjoy the rest of the event.
All right, thank you so much.
Thanks, everyone.
Well
So
done,
do we
Elijah.
just, so we
Nice
jump to the
running.
next main room, back to main room?
Yeah, so from here you should be able to leave. I don't know if there's anyone still in the main judging room, but you are good to leave the breakout room. And then I think just filling out all the judging forms is essentially the end of everything that you have to do. And we should be good from there.
Thank you.
Mhm.
So this is a new judging process. It's interesting. I'll talk to Cal about this later, but nicely done.
Thank you. Have a good one.
I'm curious, and in the
Thank you guys. It was we really enjoyed. Thanks for the opportunity.
Thanks.
yeah. So each team now is going to have scores from all the judges that were in the breakout room. Is that how it works, Elijah?
Yep. So each judge has filled out their own judging form, and then all of those will get compiled together.
Yeah, versus just having like only 3 or 4 judges in previous years.
Yep.
But as far as like normalizing across the breakout rooms, it's still going to be whichever judges did whichever breakout rooms. Is that how it works?
Yep. So the projects that were in this breakout room will only be judged by the judges that were also in this breakout room.
Right. It almost makes sense to think about having a prize for a breakout room. That might be something that we can talk about later. But thanks, nicely done.
Yeah, I think that's definitely a great idea.
Yep. Okay.
All right.
See you.
Well, thank you guys, and have a good rest of your day.
Okay.